for showing up. Really appreciate it. We are on our second meetup, and thank you all for supporting this community and showing up in time. Really appreciate it. You guys are rock star, and hopefully we'll get the same support from you guys moving forward. Before we get to our amazing talk, so sorry for this cheesy image, actually I didn't find anything there. So before we get to our main meet for the day, I have some home cleaning to do. So firstly, I would also like to thank HackReduce for giving us this awesome place where we can hang out and talk about some fun technologies. Really appreciate it. Thank you. And also I would like to thank Cognizant for stepping up and giving a free book raffle for every of our meetups. So for this one we have Predictive Analytics. It's an amazing book, and we have picked from the attendees a couple of names that we'll shout out at the end of the meetup. And if you exist in this and you're still not sleepy or whatever, so you have yourself a book. Awesome. And also a shout out to A2C for being our amazing host for food and drinks. Really appreciate it. And I think we have Matt from A2C. He'll give a quick pitch if you want. Yeah. And then we'll never said that over a microphone in my life. Yeah.
Hey guys. The shot said I'm Matt from A2C. We do a lot of big data project work, both in the Philadelphia and Boston areas specifically. We're going to have some of our guys speaking next month that are much more technical than I am, but I just wanted to, thank all of you guys for coming. We're happy to be part of this event, and look forward to seeing you guys next month, November 14th. All right?
Hi, I'm HackReduce. I see some new faces here, so I'll tell you a little bit about it. We're a nonprofit big data hackerspace, so if you like data, you are in the right place. We host events all the time here, meetups, workshops, training events, hackathons. Check out our calendar. It's online at hackreduce.org/calendar. Follow us on Twitter. We have a ton of hackathons, and the next one is travel data. I have 4 data providers, competitors even, that are bringing their data and making it available just for the weekend for people to take a look at. We have cloud computing, secure. It's going to be really fun. So October 19th, check that out. If you have any questions about the space, I'll be here. And thank you guys for coming tonight.
I don't want to waste further time. I would like to introduce Tanya.
Okay, I'm not Tanya, but I'm about the size of Yoda, so that fits. My name is Josh Walker. I'm the COO of Comlink Data. And before I hand the microphone over to Tanya to walk you guys through some of the applications we're building and to do some workshop style stuff with you guys, I wanted to give you the context for why we hired Tanya. I think that's kind of relevant to you guys. And sort of the problems that we're trying to solve and why we think about using this technology in the first place. So I'll be brief because I'm not the technical person, but I wanted to give HackReduce and this meetup kind of a sense of what it means when we say big data in the space of telecom. Okay, so Comlink Data is a company that both Tanya and I are from. And what we do is we follow people who switch telecom companies. So you switch from AT&T to T-Mobile, or you switch from Sprint to Verizon, we see that transaction. So we watch people that are switching wireless carriers, and we see 100% of those transactions that occur every day. And just to give you a sense of how big that data stream is, we see about 50 to 60,000 transactions a day. Okay, so that in and of itself is not high velocity big data, but it's big data if you start looking as far back as we do, which is back to 2004. We capture all that historical information, and we have to look at that information in a bunch of different ways to try to figure out trends in the marketplace, etc. Okay, so that's the big data that comes in. What we do then is, because we have to provide solutions to the carriers themselves, we have to tell them something they don't know. or we're trying to sell something to Best Buy or Radio Shack or Target or anybody else that carries cell phones, we have to append really smart data to that core transactional data set. And so what you see here is what we call basically our supplemental data sources. And just to give you a sense of what's structured and unstructured data, the advertising spend is something we license from a company called Kantar. So that comes in terms of unit data. You can look at how much data, how much advertising spend was in a particular geospatial area. So it's both geo-targeted data and financial data for the advertising market. Then we have demographic data. That's census data that we've incorporated so that we can tell what races or income brackets are moving more predominantly than others, right? So a new promotion comes out from AT&T. Did that move Asians more than it moved blacks? Did that move high-income consumers more than it moved low-income consumers? Then you have device data, event data, and social media data. We're not doing pure sentiment analysis, but we are doing some natural language stuff where we're trying to figure out when somebody tweets something like, I just switched to Verizon, was that a positive statement, a negative statement? Did it have anything to do with coverage in their area, or did it have to do with a new phone coming out? So we look for words that kind of give us hints and some intent on the consumer's part. Okay? Any questions about this? So before I even mention things like Hadoop or SQL or anything else like that, I think about this as the complication of our data system. So when I'm interviewing candidates and when I'm thinking about what we need to hire for our team, I think about people that have very different data skills, right? Some people need to be able to ingest, transform, load this stuff. Some people need to think creatively about how to integrate these different data sets. And then obviously some people need to be very good at visualization. Yeah.
I just wondered, where do you collect the data? Is there any central database?
Yeah, there's nothing that's centralized for sure. In fact, the company's 3 years old and we spent the first 2 years figuring out how to bring all this together. So the underlying database is the actual network that helps people route their phone calls. There's a bunch of different databases out there that make the telecom industry work. The founder of the company, former Telecom management consulting guy, just knew that this data was out there, but you had to make sense of it all. So there's a lot of bad data, a lot of it's dirty, we have to clean it up, we have to figure out what it says. And once we get that all into the core system, which is the middle database, we can start appending all the supplemental databases to it. It makes sense. Yeah?
So how much data do you have about the person in each transaction? Do you have like their name, address, and all that other stuff to be able to get to the demographics and other joins?
Well, that's a really good question. So the question was, how much data do we have about each transaction? And the real answer is we have the telephone number and the carrier, the winning carrier and the losing carrier. And then we use all this other supplemental data to derive other information about that transaction. So we have no PII.
So how do you join it to demographics?
Tanya can talk a little bit more about that, but we also, we're using the census data. So we were using deciles, and we've changed the way that we're doing that so that we can actually figure out what area of the population is moving based on where the number is. And those numbers are usually assigned to what are called rate centers, which is where a phone number moves and gets ported through when it actually gets signed up. So we can assign it to a geographic location and then learn about that geographic area based on that.
Question.
Yes?
Can you build any prediction models to see who might be likely to switch?
Yeah, so the question was, have we done any predictive analytics? And we've done some. We do it more on client requests than we do make this sort of a predictive model. This is supposed to be more of a real-time, we position it and we sell it as a real-time competitive intelligence solution for the wireless industry. So we're not trying to predict churn. We know that this data can probably be instructed into what's kind of happening next, but we're not spending a lot of time doing that. Okay, so what I want to do too is, because Tanya's going to get into the real details, I want to give you a very high overview of the architecture here. We have recently started working much more with the cloud. We've started to run some Hadoop jobs. We're starting to convert some of our stuff into Pig so that we can do some more data flow work on the front end of our system here. But the back end is still very heavy SQL. And we have a lot of folks that are still doing a lot of SQL. So that's the core of the system. And as we move sort of into the Redshift environment, we're using more and more of the Hadoop and Pig and languages like that. We are also, if you take the application query stuff, we're building our own front end. We just believe that we have to deliver customized solutions to the business user. The business user wants to see our data in a way that perhaps Tableau or Cognos or any of these off-the-shelf tools can't really allow them to customize. So we're building our own front end, and so some of the stuff Tanya will show you is how we prototype rapidly to get to the type of solution that we want for our user. And that's really what RShiny, I think, has been so helpful to me as a business user when Tanya can whip something up very quickly and say, hey, would it be good to look at it this way, or would you think the user would want to see it this way? And it's given us enormous flexibility from that perspective. Okay, so without further ado, I will sort of introduce Tanya to go through sort of how we're using RShiny in our environment and how we're very excited to be using our studio as well when that's ready. I look at both of those things from a technology perspective is if there's support for those, if they're production ready, we want to be using those technologies because they've given us enormous flexibility to prototype applications. So I think they would be really welcomed by our clients in a production environment. Tanya is phenomenal. She does a bunch of different things that are great. She not only helps us figure out how to build our applications, but she does a bunch of cool stuff on the side. She's a big sports fanatic, so she'll show you probably some application, or she'll at least reference it. She's super psyched about it, where you can do your fantasy draft stuff using this stuff, which is really cool. And she also has a really cool application that I looked at before I hired her when I was recruiting her, which is called Music Roamer, and it allows you to very much kind of semantically look at the different bands and how they're associated with each other. So if you go in and you pick U2, you see all the bands that are associated with U2. It's pretty cool. She pulls it all off of Last.fm. It's cool stuff. So I think you're going to enjoy this talk, and I didn't stand up because I was going to be able to hold the microphone. We are looking for great people. We are looking for rock stars. If you want to chat with me, I'm happy to talk with you later. Tanya.
I wanted to thank Vishal again for inviting me, and I'm excited to see this new Meetup group evolve and flourish, and I'm excited to be a part of it. So thanks Vishal, thanks HackerNews for the space. So this is a slide that really shows our web application and front end. But the truth is, I really don't live in this space on the left here. So jQuery, JavaScript, HTML. I'm going to probably trick myself with this. Hold on. I'm on the data side, so I'm writing SQL queries either from R, just straight SQL onto the SQL Server, Amazon Redshift database. So that kind of became a problem because I had all these ideas where I was analyzing data and I was coming up with cool visualizations, but they weren't tangible. I could only host them on my local machine, or I could only put them in slides. So I started looking into something called RShiny, which I'll get to, but that's the whole point of kind of laying this out, is that I'm not a developer, but I'm able to put together web applications. I'm going to show you how to do that. So how many people here have heard of R? Most of you. How many of you have used R? Good amount. And how many of you have actually used RShiny? Okay, good. So hopefully you guys will still learn something, but it looks like a lot of you will learn something about RShiny, so that's good. R started out at the University of, I believe, Auckland, New Zealand, by a couple. It was founded by a couple of statisticians, one of which was a bioinformatician. So it's a very statistically oriented language by nature. It's founded by statisticians, and it's very academic based and focused because you have all of these PhDs, mainly bioinformaticians, really, that contribute all of this. These really cool statistical packages to CRAN, which is ours, kind of repository similar to Perl CPAN. And you can, if you want to do something like a mixed effects model, or you want to do k-means clustering, you download the package, you run it on your data, all of the hard work, and then those smart people have done for you. So chart right there is actually R packages that have been contributed over time. As you can see, there's this kind of perfectly parabolic pattern where it's skyrocketing. And I want to say right now there's about 5,000 contributed packages. I want to say 1,500 or so are purely for bioinformatics. And I started bioinformatics, which is why I started out using R. So this next chart is showing the number of posts that are R-related on the left. SAS is next, SPSS, and Stata. And the different colors are cross-validated, Stack Overflow.com, and TalkStats. Massive difference. The last one is our percentage of posts on Stack Overflow in the blue versus SAS in the red. And some of you, a lot of you are probably familiar with SAS, SPSS. They're proprietary, paid-for solutions. They, to my knowledge, don't have as much of a community-contributed packages that R does, and I think that's part of the reason R is getting so much popularity, is that it does a lot of that hard work for you. It's also free, so the price is always right, especially in startups where we're obviously strapped for cash. So here are some more reasons why I personally always advocate for using R in any type of data-oriented startup or company. Number one, your code will be testable. There are packages called RUnit. There's something called test that, and you can write unit tests to test all of your code. Does everyone remember the London Whale affair in 2012 with JP Morgan? So there was something like they reported a $2 billion loss, but it was probably close to analysts were saying 5 to 6 billion. And it was, they believe, partially due to Excel error. So a financial analyst was building a value and risk model in Excel, copying and pasting a bunch of values. There's obviously no version control or auditing or tests unless you're writing macros, and I don't know who wants to do that, not me. So testing is very important. Not only that, but reproducibility. You can comment your scripts. There's multiple ways to ingest your data, be it through flat files, databases via ODBC or JDBC, rcurl if you want to just call some data from the web. Whereas if you've just got Excel or SQL statements, no one can just take your script, put it onto their computer, run it, and get the exact same result. It's much harder, especially if you're pulling in all kinds of disparate data sources, which we all know is a pretty common thing. And lastly, it's scalable. What's the row limit right now in Excel? Does anyone know? Column limit? So no one uses Excel? Cool. Yeah, there's some kind of limit now. You hit limits. A million rows, okay. Tableau Public can give you a million rows nowadays, which is pretty. I'm not just an Excel hater. Excel's good for what it's made for, and I think it's made for iterating quickly and doing things on the fly, building tools that are maybe used for yourself. But anything that's going to be used in production needs to be testable, reproducible, and scalable. And the scalable aspect of R is that you've got all these packages that do parallelization for you across distributed systems, such as the ones I listed here. So what I've noticed, and probably a lot of you noticed, we've got two sides of the spectrum. We've got web developers, and then we've got data analysts like me who just love the data, get into the data, hack my way around Perl, Python, and R, but I know nothing about, I can modify CSS, HTML, I know PHP, but to build a web app from scratch, it's going to take me a lot of time. I need to learn a lot of different skills, especially to do it properly. So the point being here is that we've got these two mutually exclusive sets of skills, right? But all these companies are they're more and more focused on data. They're more and more data-centric. Either your product is your data, or you're a company that wants to use internally generated data to optimize business decision making, or just optimize the way you do day-to-day business. So finding people with both sets of skills, I think, is very rare. You're a unicorn if you have both of those. You can build a full-blown scalable website as well as run some crazy Bayesian classifier. I think teams and product teams will be better off actually using tools such as RShiny. So Shiny is basically a framework that allows you to build web applications in R, no JavaScript, no HTML, no jQuery, and you can have fully functional, interactive web apps. It was developed by the guys at RStudio. Now, some of the features, it's easy to use, at least I think, because they have all these readily available widgets, which you'll see. There's no HTML, JavaScript, or jQuery, like I said. There's this fast bidirectional communication, which really just means R can directly interact with the web page without going through server or middleware, so it's fast. It uses Twitter Bootstrap, which a lot of you are probably familiar with if you have done any type of development. It just gives you really nice CSS templates and lets you lay things out nicely so it looks nice. And it uses a reactive programming model, which I'll talk about next. So reactivity is something I think I'm still wrapping my head around, but the whole idea of reactive programming is that you have these sources, reactive conductors, which I won't talk about right now, keep it simple, and reactive endpoints. And the simplest structure you'll typically see is a reactive source to a reactive endpoint, where most of the time a reactive source is going to be something like an input on a web page, so a slider, a drop down, and your reactive endpoints are going to be your plots and your tables. And reactive programming is basically the idea that you have reactive values, which could be like your input on a web page, and then you have reactive expressions. And reactive expressions keep track of these reactive values. So whenever these reactive expressions are executed, they'll automatically keep track of what reactive values they've already read. So as soon as those dependencies change, the reactive programming model knows what it needs to update. So as an example, as soon as you change an input on our RShiny app, it goes through and looks at all the plots or tables that are dependent on it and updates them as it sees fit. And you don't have to worry about any of that. Typically, you have to write event handlers and deal with moving data back and forth. So that's a nice feature. And I'll show an example of that as well. So before we actually look at an R app, there are some other libraries I wanted you to just be aware of that are at your disposal that are really cool. R-Charts is one, and what it does is it allows for building D3.js charts. Right? Are you guys familiar with D3? So instead of having just static plots that R can produce, you can use just R code. It's that simple formula right there actually generates D3.js code that's fully interactive. You can plop it into your RShiny app. Much sexier than just using ggplot or some of the basic plotting functions. Another really cool library that I've been using is Google Viz, and this just basically allows you to access the Google Charts API from R. On the left, you see a typical core clef map where you can overlay values onto the geographic locations. And on the right is the Google Motion Charts, which you guys have probably seen. If not, I'll probably actually have a demo of that I can show later. But things move and you can change values and parameters, so again, it makes your app a lot more interactive. And no JavaScript or coding necessary. It's all you're still in R. The nice thing also about this app is that, this package, is that you don't have to upload your data to Google. And typically using Google Charts you do. So you can do it all within the security and safety of your production environment. So you can write all of your UI or it's technically your UI.R file. We'll get to that in R. But if you are the type that does know JavaScript or jQuery, CSS, and you want more flexibility, you could define an HTML UI file instead. So typically you just have a server.R file and a UI.R file. But instead you change up your directory structure to what's on the upper right corner, and you pop an index.html file in there instead of UI.R. And you can see that the code, it just goes from, we've got our code here, and you can get the same result using HTML labels and options. So I think now is a good time for everyone who wants to follow along. We can start up R and build a Shiny app.
RShiny.
Yep, R Studio.
Good question.
Yes.
What version of R charts work with?
That is a good question. I am using the development version because I'm using all kinds of new features, so. I'm on R3.01 on this machine though, if that helps.
Excuse me, question for you. It says on my version that installing RShiny doesn't work under 3.01 or 3.02.
RShiny saying that?
I went into RStudio and said install packages RShiny.
Oh, it's just Shiny.
Oh.
Just the word Shiny, all lowercase.
Right, thanks.
Wow. All right, so give me a second to get it set up here.
Increase the font size a little bit.
Yeah. Did I increase it at all? Alright, how about this? I'm going to increase the view here. How's that? Good? Okay. Alright, so you've got your two files. So there's the server.r, and I like Sublime Text personally, because you can do these cool things like lay out, have two columns and lay out your view however you want. So server.r is the file on the right, UI.r is on our left. And right now I just kind of have the bare bones structure set up. So if you're following along, you can just set up your two files, server.r, UI.r, put them in the same directory. And then on server.r, we start off just loading the Shiny library. And then we initiate Shiny server. So this side of the code is doing all of your kind of back-end computation. This is where we put our code that does the stuff that we want. The UI.r is where we put our code to display widgets and components. So the Shiny server function takes an input and an output. And this input object is referring to inputs that we're going to specify here, such as numeric inputs, checkbox inputs. And the output is going to specify the plots and the tables that we want to render based on those inputs.
How are you opening that server.r?
It's just a text file. You can start two new blank files and save them as server.r, UI.r, open them in any text editor, your favorite text editor. All right, so does everyone have that? Let's follow along the server.r part at least. Just stop me if it's too fast. I'm going to get rid of this for now. And now on the UI.r side, we have our Shiny UI, which is going to start referencing Twitter Bootstrap components. So the page with sidebar tells us that we want a page with our selection menus on the left, that's our sidebar panel. Our header panel just displays a title, which we're calling test. And then there's the main panel, which displays all of our charts and data tables. So that's just the bare bone skeleton of the app. So if you've got that all set up, save the 2 files. Does everyone need that back up? You don't need the comments. Just I'll get rid of those. It's just that. Any questions so far while we're waiting? So this demo app is not going to have any of the cool art charts and Google Viz stuff that I showed you because I wanted to keep it simple, but those are tools at your disposal to play with when you get home and to just toy around with, especially if you're familiar with R. And I'll show you how you can substitute those in place of the boring looking plots. So everyone's almost all set? So if you've got those 2 files saved, what you want to do is navigate to set your working directory to wherever you save them. So I saved mine in a folder called reactivity. And you're just going to load up, make sure you load up the Shiny package using library Shiny. And then you're going to call run app. And that's just saying to run the app from your current working directory. So here's what it looks like so far. There's nothing there because all we specified was the header, but the components are actually there. We just haven't put anything into them yet. So we can get to that part. So then we're having issues with that. Are you able to run it? All right, so we're going to just take a sample R data set called Faithful, which is a built-in RShiny app, R data set that looks like this. So we've got eruptions and a weighting variable. I'm not sure what it means, but we're going to use this data set because it's built into R, easy to use. So let's display a histogram of that. You do hist, faithful eruptions. And we get a histogram that shows you the eruptions, and it's in R, which is great, but we want it in our RShiny app. So what we'll do is we'll go over to Shiny server. And we'll specify our output object. We're going to call this plot out. And we're going to give it this reactive value, which is really just a plot. And we'll do the same exact thing that I just did in R, but we'll do it here. And I'm going to specify a new parameter called breaks, which is going to specify the number of breaks in that histogram. And we're going to have breaks be an input object on the UI.R. So we'll specify the breaks parameter as a numeric variable, input, and then end breaks is what we'll call it. What's that?
What's the symbolic phrase?
That's the fateful $ eruptions.
The breaks dollar has numeric all or
Breaks equals.
okay, sorry. Thank you.
So next we'll add, we're also going to want a table of that data because, as you probably know, we like to also see the data that makes up charts. So we'll specify an option for the user to actually display that data or not. And that will just be an if statement where if input, it's going to be an input option called individual obs for individual observations. And then this rug function just on the histogram will plot little points of where those data points actually are in the histogram if that option is selected. All right, so for now that's our server.r. Let's go over to UI and actually tell the UI what to do with it. So in UI, we just have to add our inputs. Which, for the number of breaks, it's a numeric input. And the variable was called end breaks. And this is what we want it to display as, which is number of breaks. That's how it'll display on the sidebar panel. And then you have to give it a default value as well. I'm just going to give it 10. And you need to put a comma at the end of each of these input options. It's just essentially like a vector of options. So the other option that we have is show those individual observations, which is just a Boolean, so it's a checkbox. So we're going to add a checkbox input. And it was called individual obs. And we're going to call this show individual observations. And I'm going to default that to false. So far, does this make sense? We're connecting the input objects to the output objects in server and UI. All right, so next, we have to tell Shiny that we want to plot in our main panel, which is most of our real estate on our screen. So here we're going to say, we're going to reference our, a function called plot output. And then we have to give the name of our plot which is plot out. And if you want, this is where you can also specify a width option. So I'll just give it to 700. Right? And save. So now I'll go back to R, and I'll just run my app again. Oh, and there's the syntax error. All right, so the syntax error was in server.r. So
I think there's a missing right.
Try that again.
Get mismatched parentheses.
It's really hard to see. It's hard to see.
Is there not supposed to be one after eruptions?
Oh, no, thank you. This is a weird angle. Okay. Good eyes. All right. So now we've got something that we can actually work with. So we've got our plot, we've got our, on the left there, underneath test, that's our side panel. Test is part of our header panel. The histogram is part of our main panel. And we can actually interact with the data now. So if I want to change this number of breaks, I'll say 100. You get more granularity in your histogram. And I might want to show those individual observations, which you can see these little lines that might be tough to see, but underneath, above the numbers, they appear, disappear. So that's just the plotting part. Are there any issues with that?
We want to go back to the
Yeah.
second. The UI side. I want to make sure I got it right.
So while we're in UI, let's also add, everyone's probably familiar if you've used R with tables, just data frames. Let's actually show the values in an actual text table. So the way we can do that is underneath plot output, add a comma, we're going to say table output. And we'll call it table out. But we also have to specify what that is in server.r. So here we'll provide our output object again, and then we'll call table out, which we just specified in UI. And now we're going to give it another reactive value function, which is called render table. Makes a lot of sense. And now we added that individual observations parameter, which will also act as a way to control whether or not this table is displayed. So we'll add another if statement and say, if that same individual obs checkbox is checked, output the data. And you can literally just give it your data frame, and that render table function will know that it's supposed to output it just as a table as it is. That's not checked, we want to just return null, which will do nothing, and it will just look like it did just now. So if we go back, we can actually just refresh. All right, so we're back to 10 observations. Let's do 50. And now here's your table. You can check and uncheck. You can scroll down. Now, if you're more on the CSS side of things, you want to make it prettier, first I definitely recommend using R charts and Google Viz to make these a little nicer looking. But if you're into CSS, you can actually do things like, well, I like Chrome's element inspector, but you can go in and actually see all the different classes. And then you can actually provide your own CSS file for the Shiny app, and that's a little more complicated. I'll show you the code, but you probably won't want to just type that all up now. But there's basically a custom header panel that you can provide, which is all here. And what this does is there's a bunch of tags. There's a tags list which will basically transform all of these tags. So a head tag, for example, or a title tag, it will actually transform them into HTML tags, heads, titles, and you can provide references like this. So here's our style sheet, and I'm going to give it this app.css file, which actually just lives in the same directory as your server.r and UI.r, but you should have a www directory within that, and in that directory is where you put your CSS file. So we save that, but then we have our custom header. We have our header panel right here. Instead of the generic default one, we need to replace that with custom header panel. So now it'll reference that, and it'll pull in our CSS file. And just to give you an idea of what that looks like, I've got it loaded right here. This well is our menu right here. So that's specifying this object, and I found that out just by inspecting the different elements. So right here, you can see it says form, the class is well. So we know in the CSS that's what it's referencing. I don't like how long it is. There's a bunch of unnecessary space there. So I'll uncomment this, and let's make it 250 pixels. Really basic CSS. I really don't know much when it comes to CSS. And now if we refresh, it looks a lot better. So that's kind of the way I go about it. There's a bunch of different ways you can do this. I highly recommend, I'll put the code back up if anyone's finishing up. I highly recommend using the RShiny Google group. So they were really helpful and supportive for me when I was going through learning all of this. There's an RShiny tutorial on their site, which basically has the same example. I might have modified it a very little bit. But the guys on the Google group, I think Joe Chang, Winston, they're really helpful. They work at our studio, they develop this stuff, and they're just doing an awesome job. They've been super helpful for me, so I highly recommend it if you want to start getting more fancy. And I think lastly, I'll just sum up with showing a couple of fully fleshed out examples. So I've got 3 apps I want to show, and let's see if I can actually just run them locally. So the first one is an app where we're collecting Twitter data. Alright, so this is one of the apps where we're collecting all this Twitter data on switching activity, people mentioning Verizon or T-Mobile and the word switch or switching, and I just wanted to visualize it. I just wanted it accessible to everyone in the company. So you can come in and you can select different categories. So we're observing things like people talking about their phones. I can come in and select phone, and you see it pop up here. We can filter by the different carriers. This is just showing raw volume numbers of tweets. I can take Verizon out, I can take Sprint out, and this is using the RCharts library. I did zero JavaScript coding to do this, and it makes me look like I'm a developer, but I didn't have to do anything to get all these fancy filters. So it's really cool. It's very simple, I think, once you get going and really start diving into the code. So that's one example. Another one that I wanted to show quickly was maps. So using the Google Viz Core. So this one's actually querying Amazon Redshift with some of our production data, and I'm using our PostgreSQL to connect to the database. We've got, I obviously modified the CSS to get our logo up there. This includes some more widgets that we didn't go over, like drop downs and a submit button, which allows instead of updating immediately as you change different options, it will wait until you press that submit button, which is really useful. So what this is showing is a Google Viz map, and it's showing win share for Verizon in 2013, the second quarter, by DMA, which is a direct marketing area. It's what marketers use to target their customers. And another thing I did not get into was an R charts component called data tables. And this is, if you're familiar with jQuery, JavaScript, data tables is a really popular way to show data in grids like this. I can search, I can specify the number of entries, I can sort columns, page through, and again, just no JavaScript, so it's really cool. Use the package if you can, contribute to it if you're very ambitious, please do. It makes people like me look like web developer rock stars. The last one is just what Josh mentioned, a kind of fun project. This was my first app that I built. A lot of late nights with fantasy football data and beer and anticipating the Patriots season. So, personal plug, I run the sports data viz blog where I play with sports data and visualize it. And I think I have internet, so it should be loaded. Oh, there it is. Okay. This was really, I just dove in head first and learned, I wanted to do this. I had the data. I was scraping fantasy football mock draft data from fantasyfootballpros.com. And I had it all in a Postgres database on Amazon, on AWS, and I was like, well, I need to do something with this data. So that was my way of diving into RShiny, really learning what the heck I can do with it. So I've got, I believe it was 19,000 mock drafts, which is some 3 million plus different picks. And I took the data, and in R, I actually calculated how many times each player was drafted before another player, and then they were given a power index. So Adrian Peterson, obviously #1 draft in most leagues, he has the highest power index. Everyone else is ranked, descending order here. So as I'm drafting, and say I want to draft wide receivers, I can filter. They're all sorted by power by default. And then you can actually visualize, this is just a GG plot. I can see the average power remaining by position. So as you're drafting, you can actually say, well, Calvin Johnson was drafted, he'll disappear, and then your chart gets recalculated. So that's an example of the reactive model. As soon as you trigger these inputs, those reactive expressions know that they need to update themselves if they're dependent on those inputs. And then just to show you how I leverage R charts, I wanted to compare two players. So maybe it's time to pick a quarterback and you just have no idea who you should pick, or you've got two in your head that you're going back and forth on. And for fun, let's just do Eli Manning versus Tom Brady. All right. Tom Brady's the black, and this is average draft position on the left. So he was drafted, Eli Manning was drafted 0.165% of the time before Tom Brady. That's just a text object that you can use. It's called rendered text. This is another data table, and this is one of the R charts that you can use to generate these cool interactive charts. So I can filter, I can hover over and get a tooltip. And then I've also got these tabs, so RShiny allows you to incorporate different windows and different. Notice that when I go to compare two players, the options change. So you can, there's really a lot of flexibility. I think it's really a tool that's changing the way that data teams are going to work together with development product teams. I'm able to whip these up pretty quickly and allows our internal users to test, maybe refine the requirements or figure out if there are any bugs. But it really lets your data team focus on what they're good at and what they can do. They can then present their analysis and then allow your QA and testing to be done. When you've got your kind of final specs and requirements, ship those off to your product team. Now you save yourself some iterations because the data team's already really hammered down what they want to do. So that's it. If anyone has any questions, feel free now. You can talk to me after. So that's something called, look up conditional panel, and then that basically allows you to you name the different tabs, and it'll say if the tab is, you know, tab 2, and then you can provide it all of the parameters here just like you would.
So you put your site panel code inside the main panel? Is that what you do?
Yes, I believe so. Hold on. That code is actually also all available on my GitHub. So let's do this. So if you go to gist.github.com/tcache21, yeah, hold on, I just gotta load it. Okay. So here's the code for the fantasy football app. I've got my CSS at the top. But let's go down to the conditional panel. This is a global.r, which I didn't mention, allows you to specify variables or any type of data that you're going to use across your application. And server, as well as UI, has access to them. And it just loads them once at startup, and then you have them. Now this code is a little bit different because I'm actually using Postgres, and I'm querying the database. This was when I originally just used R objects for the data, so it wasn't as dynamic, it was just static objects. But the main ideas are still here. So this is my server.r. Let's go down to UI, because that's where the conditional panel is. All right, so you can see here, I've got a conditional panel, and then I say condition equals, and you give it your input, and then the tab. This is your tabs 1, is your list of tabs, and you just give it the actual name of the tab. So in my compare to players, I have all of these different parameters. And then you can just specify another conditional panel. This is my power by position, my first panel, and again, specify all of the things that you want to show. And here's what the tab set looks like. It's just a tab set panel, and you provide it multiple tabs.
You're running this all on your single machine, right? It should be able to run the Shiny on a server and have your application running on it.
Yeah, so I was running the demos you saw on my local machine, but the fantasy football app is hosted on AWS. And at Comlink Data, we actually also use AWS. We've configured RShiny server on that instance, and we firewalled it to our office so we can actually, everyone in the office can access it through a URL.
Now, is that a lot more complicated?
It's actually not that bad. There's a bunch of tutorials out there. Someone wrote an AMI, which is fully configured for, I think, Ubuntu, or a Linux AMI with RShiny already configured. So there's a couple walkthroughs out there that you can look up, and I could comment where they are on the meetup afterwards. Yeah.
With the data for capability, like with Sharp, is that something you can set up?
What's that?
Drill down?
Yeah.
You do drill down, you just set that up, preset it up in the data set, and then the other question would be, you had a drill down that's not a direct drill down, that's for grouping or something like that, you're actually going to a different panel, is that something you can set up easily, or?
So are you thinking along the lines of, you know, we've got some inputs on the left-hand side, and we want to drill down into maybe from states to cities to.
Right.
You know, I haven't done that, but I'm sure it's possible. You could specify. I'm not sure the best way to do it other than just a drop down. But you can definitely specify a drop down and just step through each value that you want.
But it's not interactive on the chart itself.
So I actually, it's a good question, because the other day I saw an example where there was someone was using a leaflet, which is part of our charts, and it's a map, and it allows you to, as you zoom in on the map, it updates all of the listings of cities that are actually visible. So you can do it. It takes a lot more massaging, but you can use things like that to drive, as inputs basically, to drive outputs.
So what are the typical business cases where you are asked to build something like this?
Yeah, so the ones I showed between the Twitter example, but really the mapping one was a big one. So let me just bring that up again. So the big thing here was, our CEO kept saying, I want to see a map, and I want to see win share, or I want to see wins. And at the time, we were going through some turnover. Obviously, hiring good developers is hard. We weren't able to just get it up there for him, for somewhere that he can see and play with the data. So that's one instance. I was like, well, I can use Google Viz. I've got the data. I can query our Amazon Redshift instance, and he can go through now and select, the different carriers. We can go ahead and level the playing field, so to speak. So Verizon is doing really well in all these areas, but what if we only look at areas where everyone has at least 90% 3G coverage? So this was a cool thing you could do too as well. Shiny's loading, or while it's busy, you can specify this little animated loader so that people aren't just sitting there waiting. Okay, so it doesn't look like they're doing anything too crazy up here because they actually, they're the only ones that have coverage up in Montana and this region. So now you actually see, well, where are they really doing well where everyone else has a fair shot because they all have 90% 3G coverage. So this is another instance where we can quickly add these options. I think that was one of the gotchas or the what ifs that our CEO came up with. He came back and he said, well, I want to see it with comparable 3G. So that was an option that I could just quickly add. It's also really useful for internal tools. So you might have business analysts or any type of analyst that needs access to the data in a way that will help them either at a client site or with their own just day-to-day work. And this is also a really cool way to just internally visualize your data, interact with it, and give them the tools they need to just do their day-to-day job.
So to deliver this to them, you set up the whatever server UI apps you had, our files onto his PC, you gave him a script to kick it off or something?
No, we configured our RShiny server on an Amazon EC2 instance, and then I can just literally send him a URL.
Yes. Thank you.
Is database calls, or is it all database calls on the AWS, or is it sort of locally?
Yeah, so our AWS, this one actually is, even though I'm local right now, I'm actually calling our Amazon Redshift instance. So in our production version, that does the same thing. It's making choosing our PostgreSQL to query the data live and bring it back. And the next step is I actually want to configure, it's called Mondrian. And what that does is it allows you to query an OLAP queue, which when I run queries like this, it will cache the results on the front end so that the data's there. It's much faster if you go back to that data. That's the next step. All right, any other questions? Yeah.
How's your power ranking metric doing so far this season?
That's probably the best question of the night. I'm in a paid league. I'm also in a non-paid league. In the paid league, I think right now I'm like 6 out of 12, so not so great. In my non-paid league, I'm in first place, of course, but I'm playing with a bunch of Giants fans, so.
The people who took me left first?
What's that?
The people who took me left first?
Yeah, actually one of them took like 5 Giants players, so they're struggling. All right, well, I hope you guys learned something, and I can make that code that I had up on the screen available, but most of it's already on the RShiny tutorial site. I'll post it anyway. Because it does have that custom header panel that they did not have on there, that I had to go searching to find.
Is video going to be available?
Yes. Yes, video will be available. That was the question. All right, thanks.
Thanks, Josh and Tanya. Amazing presentation. So hopefully now we know where to go for our fantasy football picks. Thank you. That's a great. So for the predictive analytics draw, I have a couple of names I'll throw in, and if some guy is there, just let me know. Thomas Emerson. Eileen Butler. Raymond Venegas.
Right here.
Nice. All yours, sir. Thank you again for coming, and hope to see you again in our next meetup. Thank you.